Very much. All right, so we're going to do this sort of like, I guess, stand-up comedy because I have a handheld microphone right now. So who am I? As was mentioned, I'm a technology evangelist at Docker, so I work for Docker Incorporated, which is the company behind the Docker project. I spent the first half of my career doing IT networking and sysadmin stuff, but that was a long time ago. So I was a certified Banyan engineer. There's always like one or two people that are like, wow, that's old. And then I was a Microsoft certified systems engineer on Windows NT 3.1. So that's how long ago that was. So then I moved in, second half of my career, I've been doing a lot of product management and technical marketing for Docker. Most recently, before that, I was at Puppet Labs. So that was sort of my open source exposure coming into Puppet Labs. Before that, I spent about 6 years at VMware, sort of from 98 to 2008, 2015. And then before that, I spent about 6 years at Microsoft, where I did a bunch of stuff on IT admin features and functionality for versions of Windows, starting with Windows 2000 or NT5, whatever it was called. If you've ever installed Windows XP and you've ever read the text that says Windows XP will be faster and more reliable, I wrote that text. So that's my claim. Well, my other claim to fame at Microsoft is I was on stage with Bill Gates in an earthquake. So there's that too. I come from an IT pro background. I'm not a developer. When I pretend to be a developer, you'll see painfully, obviously, how I am not a developer. But if we get to a demo, then we'll see that. You can follow me on Twitter. I tweet mostly about soccer and the Portland Timbers, occasionally about work. So why are we sitting here today? So first, I'm going to start with the informal poll question. We'll start at the high end and move down to the more beginner end. How many of you are deploying containers in production today in your company or in your organization? That's actually really good. Normally, like I just did Container World, and I had a room of about 100 people, and I had 6 people in production. How many of you have downloaded Docker and have done a POC with it? So you're planning to go to production. How many of you have downloaded Docker and run something like a Hello World app or a demo app? How many of you are brand new to containers and are here because you just want to learn? It seems like the same people all raised their hands. It looked like it was about 25, 25, 25. So we're gonna spend some time on what is Docker to get people up to speed. So if you're familiar with it, bear with me. We'll get into a little bit deeper stuff. But as you get familiar with containers, as you start moving into that journey, questions come up, right? Especially if you come from, how many of you are developers? How many of you are sysadmins? So 50-50. So this talk is really aimed at people coming from the sysadmin perspective, like, what are these things I need to know about, right? So when do I use a container? When do I use a virtual machine? If I'm going to deploy containers, do I put them on a physical box or a virtual box, right? Do they go in the cloud? Do they go in the data center? All of those different things. So we're going to talk a little bit about how you answer those questions. Actually, I'm going to give you the questions to ask to answer the questions you wish that I would answer for you, because I can't answer your questions, and you'll understand why as I go through the presentation. So we're going to talk about what are containers and what containers are not. Containers are not virtual machines. Right, when I first started at Docker, summer of 2015, everybody would be like, oh, it's lightweight virtualization. Oh, I've heard Docker, it's lightweight virtualization. They're lightweight VMs. They're not VMs. They're totally different. They have different architecture. They have different benefits. So if you think about a virtual machine is a house, right? It's fully self-contained. It has its own heating, its own plumbing, its own air conditioning. It has a front door, so you can't just bust into it, right? It's got a little bit of security there, a little isolation. Think about a virtual machine. It's a self-contained operating system. The entire OS is in there, right? And if I'm running, let's say I'm running a couple of servers and they're web servers, and I need to have a third for capacity, I spin up a virtual machine, I spin up a whole new operating system. I build a whole new house. There's nothing shared between those houses, right? I would say maybe the sewer, and that'd be like the network, but that might offend the network guys, so I won't say that. So right, VMs, like monolithic, fully self-contained. If you need more capacity, you expand them out, right? Houses can be different. They can kind of look different, right? Like you can have one house that's kind of a big 2-story house next to a 1-story house, and they're different sizes. But houses only get so small. First house I ever bought was about 800 square feet. It was 2 bedrooms, a bathroom, a living area, and a kitchen, right? That's the smallest houses I could find when you talk about proper houses. I could talk about micro houses, but they break my analogy, and some of them are made out of containers, and they really break my analogy. So we'll stick on like normal houses. So, and that's like VMs, right? Even if you go and you shrink them down, you're usually looking at a couple hundred megabytes to get it in a VM, right? And sometimes you're talking 10, 20, 30, 40 gigabytes, right? They get really big. So containers, how are they different? So think about containers as apartments inside of an apartment building. So an apartment building is the Docker host. The Docker host is any computer, physical or virtual, cloud, data center, whatever, that runs the Docker engine. The Docker engine, you know, there's a lot of different container runtimes. I'm going to talk about Docker, right? But this whole idea of like container runtimes, pretty much this is exactly the same in all of them, right? So you've got a system running the Docker engine, a container runtime, and that's like the doorman at the apartment. Now, what makes an apartment different than a house? Well, one of the fundamental things is it shares the infrastructure. It shares the heating, the plumbing, the air conditioning, right? It shares the elevator. Containers are processes inside an operating system. They share the underlying kernel in the operating system, right? So unlike a virtual machine, which has its own kernel, containers share that resource. That means there's a couple of big benefits. It means there's also a couple of limitations as with respect to virtual machines. The big limitation is that every container running on that host has to be from that host family, right? So you cannot run a Windows container on a Linux host. You cannot run a Linux container on a Windows host, right? Because they share the kernel. But you can have a host that's running CentOS, and you can run an Alpine Linux container on it, or a Red Hat Linux container on it, or an Ubuntu Linux container on it, right? As long as the architectures are the same of the underlying hardware, those things are just going to move along. But like houses, we have a front door, right? So a container is isolated, can't just bust into it. And then the containers can be quite small. They're doing a kind of an informal, if you want to get on a little informal competition on Twitter, one of the Docker, I don't know if he's a captain or not, but he's an aficionado at least, a community member, a hacker, posed the question, what's the smallest hello world container you can write? So what's the smallest container you can write that says hello Docker, right? And so anybody want to guess what the size is, the smallest I've seen? 68 bytes for that container. So that's a full running container, 68 bytes. I have an Alpine Linux container that's 2.6 megabytes. That's a full operating system, right? And so containers are much, much smaller than virtual machines. The other thing, or they can be, right? The other thing is that in a container, because it's booting up a process, it's not booting up an operating system, they start really fast. They start in about 3/8 of a second, compared to a virtual machine taking several minutes to boot. So fundamental differences, shared resources versus dedicated resources, a little bit faster, a little bit smaller, but sort of very homogeneous in the network, or with respect to the operating systems you run. But just because they're different doesn't mean they're mutually exclusive, right? What you see is most people you see what's on my left, your right there, where people are taking containers and they're running them inside of virtual machines, right? They go and they spin up a Linux VM or a Windows VM. How many of you knew that there was containers on Windows now? A handful of you. Okay, I don't have that in my slides. I know this is the Linux Expo, but how many of you run environments that are 100% Linux with no Windows at all in them? So like 20%, So for the rest of you, containers are also available on Windows Server 2016. I won't get into it in a lot of depth, but just know that there are such a thing as Windows containers. They use the exact same API, the exact same CLI as the Linux containers do, right? But they're based on Windows operating systems, not Linux operating systems. So you could, in this example here, one of these blocks could be a Windows Server 2016 machine with Windows containers. The other could be a Linux virtual machine with Linux containers, and you could just have a traditional VM over there doing whatever. Or you can run them on bare metal. You can have a host OS running on a piece of hardware, and you can install the Docker engine. The thing is, it doesn't matter, right? If these are Linux containers, they can move from the left to the right seamlessly, regardless of the distribution underneath, right? So in test I'm running CentOS, in production I'm running Red Hat, whatever. It doesn't matter. We can move across there. So, and like I said, there's really good reasons for each of these architectures, and I'll get into them in future slides. So one thing I want to talk about today, with regards to the Docker project, we just announced this today. So I have this in here, and so this might be of interest to everybody. So today we announced we're actually releasing two version. So we're splitting the project, not splitting the project, but we're splitting it up into two specific releases, right? So Docker is a commercial company, right? I work for a software company called Docker that happens to manage the open source project Docker. And we wanted to make sure people understood that there were a couple different ways to get Docker. So the first is Enterprise Edition. And I won't spend a lot of time talking about this because it's a commercial offering. It's stuff that we sell, but basically it takes the Docker technologies, it bundles them up into releases for people who want support and they want some advanced features. Then we have Community Edition, which is the same Docker that people have been using forever under open source, right? So it's great for do-it-yourself organizations or hobbyists or all kinds, that kind of folks. We're going to be on a quarterly release with those. With every month, you'll get an edge. What's called an edge release, right? So what used to be like experimental or beta, you're going to be able to see like, okay, I'm on 17.3 edge, right? And that's the sort of beta upcoming releases. And then we do maintenance and support on the Community Edition for 4 months for each version. We do it for a year on the Enterprise Edition. Enterprise Edition also comes with a whole bunch of certification stuff, and I think I have a slide on that where we've certified a bunch of ISVs, a bunch of hardware. So this is new, and you're going to hear more about it, but I just wanted to bring it up since we were here this morning. We're also going to talk a little bit about additions, right? And I'll talk about additions at the end, but I wanted to explain what an addition is. An addition is any way you get Docker running on your machine. So I have a whole getting started section, but we released Docker for Windows, Docker for Mac, Docker for Azure, Docker for AWS, right? And those are ways for you to get up and running and integrate with whatever platform you're running on. So when you think of something like Amazon, it's going to take into account load balancers, it's going to take into account S3 storage, it's going to take into account the VPCs and the NATing and everything you need to run, right? It'll stand up Docker, build all that infrastructure out for you. That's something you can get with Community Edition. It's totally free. If you're running on AWS, it's the fastest way to get up and running. We'll talk about that a little bit more later. Skip this slide. So the idea basically is with the Docker platform, regardless of whether you want to pay for your software or not, we're going to give you one platform, right? And the idea here is that the promise of Docker, and at the end of the day, why people deploy it, is that they want to be able to write an application, have their developer write an application on their workstation, and have that seamlessly flow through the environment and move from developers through QA into production, right? And they want to be able to do that on Linux, and they want to be able to do that on Windows, and they want to do it on premise, and they want to do it in the cloud, right? And any type of app. When I joined Docker, everybody was like, oh yeah, it's containers, it's only for microservices. And what we're seeing is most of our customers today are not exclusively using Docker for microservices, and I'll give an example later. Companies are taking traditional applications out of VMs, containerizing them, and putting them onto Docker for a number of different reasons, which we'll go through. So if you've got homegrown applications, ISV applications, microservices, it doesn't matter, right? All of that, moving that. And if you're on Community Edition today and you want to move to Enterprise Edition, great, it'll just work. Okay, so now that I've been speaking for like 15 minutes, some of you are in there like, just answer the question. Like the question I came here to get answered. But the thing is, like, one does not simply answer the question without doing a bunch of marketing stuff. Besides, you wouldn't like the answer, right? So this picture, so when I was at VMware, I would get this question, and who thinks, I want to hear what you guys say. What is the number one question I answered when I was at VMware? Yeah, well, that was number 2, but because I didn't actually, people ask me like how much it costs, I'd be like, I have no idea, I don't sell software. Okay, so the number one question I got was, how many VMs can I run on my server? What's the answer? It depends. So I would like, if I was feeling kind of nice, I would say it depends. If I was feeling surly, I would say, how many plants can I get in my car? right? Because it depends on your car, it depends on the plant, right? So my car is a Ford Escape. I used to have a Suburban. It was a better analogy when I talked about when I had my Suburban. And my wife has a Honda Fit, right? All right, so I could clearly carry more plants than her. Well, no, because I'm carrying ficus trees and she's carrying pansies, right? So there isn't an easy answer to this, right? There's a lot of variables to consider. So when you think about and you say, okay, well, I understand what a container is, but I still don't know what I'm going to do with it. There's all these things you have to think about. So I went back and we go back a couple slides, and I talked about this idea of mixing and matching your workloads. This is all about capacity planning and somewhat about licensing costs. But if you think about where VMware came from, so 2008, VMware's really picking up steam, and the number one use case was I stand here all day. Legacy apps, sure, but the problem we were trying to solve was resource utilization, right? Because you had all these servers out there and they were all running at 30% utilized, but you couldn't mix the workloads. So then we said we put the database and the Exchange server and the IIS server into VMs, and we can now put them on one VM, on one physical server, and I now have a machine running at 80% utilization instead of 30% utilization. So I'm spending a lot less money on hardware. That's where we came from. If you're sitting there today on your first stages of your container journey and you don't have enough capacity to drive the server utilization, you'd be foolish, if your number one concern was capacity utilization, to put that on bare metal, right? Because you would be wasting money on that hardware. So capacity planning and mixing workloads. But now if you go, wait a minute though, I have a security implication, and there are security implications that say I cannot run this workload on a shared kernel. Like there's there's a law, or there's a security policy, or there's a regulation or something. Then you're like, well, what do I do? Well, I put it in a VM then, right? Because I have to, because in a lot of people still consider, well, I mean, it is a shared kernel technology, right? And so they're like, we can't do that. It's just a policy, we can't do it. So if you have multi-tenancy requirements, right, and especially in the Linux space. In the Windows space, there's this thing called a Windows container with Hyper-V isolation, which we're not going to get into, but if you're interested in that, find me afterwards and I can tell you about it. So you're like, well, I have to go in a VM, even though I have enough capacity, but so I'm going to go VM. But wait a minute. I really care about performance and latency. Well, okay, then you're probably going to go bare metal. Because containers always run faster on bare metal. They run faster than virtual machines. They run faster than containers in virtual machines. They are fastest on bare metal. So you're sitting there and you work for a financial trader in New York City, a company who just paid $70 million to relocate their data center 2 miles closer to reduce their latency by 3 milliseconds. Because they do that kind of thing when you're dealing with like billions of dollars in trades. So then you're like, well, I don't care if that server's 15% utilized. If it's 3% faster, I'm going to go ahead and spend that money. So there's that. So anyway, if you think about it, there's a lot of different variables in there. The only one I haven't really touched on is, some of you are sitting out there and you're like, well, I'm a vSphere admin, right? All my tooling is vSphere. All my tooling is KVM. All my tooling is Hyper-V. All my tooling is Puppet. All my tooling is Chef. All my tooling is Ansible, right? So you've got these existing automation frameworks, and you've got these existing skill sets. So you look at that and you say, well, it just doesn't make sense for me to go 100% into containers right now. Like, I want to keep what I've done with vRealize automation or vCake or whatever it is, right? So that's another thing where you look at it and you say, how am I gonna make this transition with my skill set and my staff and the people who have to do the work? Because a lot of people come in, especially on the sysadmin side, they come into containers because someone walked into their office one day and said, hey, the new app is ready, it's in a container, go ahead and put it in production. And you're left with this slide, and you're left with, well, I don't know how to capacity plan for that. I don't know how to, secure that. I don't know how to do that. So we're going to take a look at 2 examples, and we're going to talk about first consolidation and compute consolidation, and then we'll talk a little bit about security. So VM consolidation. So this slide is actually based on some testing we did with Hewlett-Packard. So HP, and then we had an independent consultant named Brett Fisher, went out and they took Sysbench, and they ran Sysbench. And what they did is they took Sysbench and they said, okay, on this physical server, we're going to create 8 virtual machines, and we're going to run Sysbench in them. and then we're going to measure the output. So let's just say for grins that each machine or each VM could do 1,000 transactions per second, so 8,000 total transactions, right? So then they said, well, what happens if we put that in containers? So let's just use one big giant virtual machine. So they took the 8 VMs that were using 16 cores and 16 vCPUs and 32 gigs of RAM, and they made one big VM that was 16 vCPUs and 32 gigs of RAM. You know, just again, kind of just making up these details, really. Kind of making this whole thing up. Actually, that's not true. This is actually a true study. And what they found was if just by moving from 8 smaller VMs into a single VM, you actually got 27% greater output. So where you were running and getting 8,000 transactions total per second, you were now getting 10,000 transactions per second, which means if you had a server farm out there, you could take 25% of the servers out of the farm and still do the same amount of work by moving into from a bunch of smaller VMs into a larger VM and containerizing those workloads. So if you had, each container represented a different work group or some other different workload, by bringing those together. The other thing that you've done there is you're going to use about 30% less storage. You're going to use about 7% less RAM. You are going to move from managing 8 guest operating systems in 8 virtual machines to a single guest operating system in a single machine. And you're going to reduce your data center footprint, right? So less electricity, less cooling, less real estate. I will say, so for those of you in the room wanting the technical details on this, one of the things we did have to do was it wasn't a straight just move over. We did some stuff with pinning and affinity to make sure that the workloads went to the right CPUs. And there is a 50-page white paper on this available from Hewlett-Packard. So if you follow me on Twitter, I will tweet the link out to that paper after this talk. And it goes into all the detail of how we did it, right? So if you're sitting back there, you're like, well, geez, okay, there's a benefit. So if you do that exact same experiment and you go, okay, now I'm going to take 8 VMs and I'm going to move into 8 containers running on bare metal. So no virtualization at all. You get a 47% output increase. So you go from doing 8,000 transactions per second to about 12,000 transactions per second. Again, I'm just using those numbers to make them easy to, because they're even whole numbers. But what it basically means is if you were doing a server farm, you could take 2 of those servers out, right? It's a little trickier if you say, well, I only have one server doing the work because of the affinity and the pinning. So that sort of example works better when you talk about using server farms. But if you were just on a single server, you would still get more output from that box than you were before. So again, storage savings, operating system management savings. You go from managing 8 guest OSs and 8 virtual machines to running a single host OS running on bare metal, right? So you have the bare metal server, your Linux operating system, and the Docker engine, and 8 containers out there running. So that is, the VM to bare metal consolidation. So things to think about then. So you're like, all right, so that's interesting. So what do you got to do, right? So higher density. Containers are going to give you higher density than you're used to having. So just think about that, right? They because they're lightweight processes, you're going to just get more of them in there. They're going to be more responsive. Bare metal or bigger VMs, right? So do you want to now look at getting rid of virtualization altogether in some use cases? Well, if you don't have to worry about multi-tenancy, right? That's if your existing tool set lets you do that, right? Then you can get performance gains there. So you have to balance those things out. And then tuning to optimize. So I mentioned this before, right? We didn't just slam those VMs and just move them over, right? We had to do some work with the affinity and the pinning on the CPUs. The white paper details exactly what we did, but by tuning it a little bit, right? And it took the consultant, a couple days to figure that out, right? He made an investment about, I think most of us would invest 16 hours to get 47% performance gains. That's a pretty big return on your investment there. So that is, the idea of capacity planning and a real quick overview on that. But that's an indication of the things you need to start thinking about. We're not, you don't want to just go into it on this mindset of, oh, they're exactly the same. We can just sort of do this one-to-one mapping because things are going to change for you. So what about security, right? I put this in here because probably the number one well, it's not really the number one, but one of the top 5 questions I get about Docker containers is, what about security, right? Most people, when they say Docker container security, they worry about like exploits that allow you to break out of the container, which have happened, right? They've been there. We work very hard to protect against those, as do all the members of the community. But security is more than that, right? When we look at security, we think about end-to-end security. And how you can do that. And we look at it now from this perspective of, like, there's 3 things that we really care about with security. The first is that it's usable. Because if you make security unusable, if you make it hard, they're going to circumvent it, right? They're going to write that 15-character password on a Post-it note, and they're going to slap it on the side of their monitor. They're going to use the same password for every system. Like, I'm guilty of that. I'm not guilty of that. Do not try to hack me. Anyway, so we know this is a common edict, right? And you want to have a way to move things around in a secure manner, right? It's not just about like what's happening when the container's running, but what happens in that application through the entire life cycle. How do I guarantee that the application that I'm putting in production is what I think it is? How do you know when you deploy a VM that it's actually the VM you think it is? How do you know that somebody didn't come in and swap that VM out? And you're looking at it and it says master golden image 216.2017.7, and you think you've got the right version. How do you know that I didn't come in last night and change that and just rename it? You don't. I don't think. Maybe you do. And then whatever you do with that container, whatever you do to define that security policy, it needs to follow that container regardless of where that container exists. Infrastructure independence, right? So my security works on my MacBook, my security works in the cloud, it works in my data center, right? All of that equals safer apps. So how do we do that, right? So things to think about when you're looking at deploying containers in production and around security. One is application secrets. How many of you pass? Okay, we're going to do it like they used to do in Sunday school. Everybody close your eyes so nobody has to be embarrassed. How many of you pass passwords using environment variables or in static config files? Come on. All right, there's a few brave souls. I think more people than raise their hand do it, right? We all know that there's an inherent risk in that, right? So how do you pass that stuff securely? How do you maintain a workflow that works for your developers and your operations team? And then how do you set up a system that out of the box is already secure? So we're going to talk about those things in a little more detail. I think, hold on. We're going to talk a lot about secrets. So in here, the image signing and image scanning and verification. So these are functions available through Docker. Image signing and verification is fully open source. It uses something called Notary, which is based on the update framework. The image scanning is actually a paid service that you can have added to your private repos on Docker Hub, or you can have it added to your Docker Data Center Enterprise Edition thing. But what they do is they work in concert. So the idea is, with image signing, I, as a operations person, provide a base image to you. So you're going to write a Java application. So I hand you a Java image, and I've signed it digitally. So as a developer, right, as an operations person, you can configure Docker to only run signed images. So I'm a developer. I pull down the Java image, and I try to run it. Docker verifies the signature. That runs. I add my code. I sign it. So now it's been signed that it has the right base image. It's been signed that the application you're about to deploy has come from one of your developers, right? And then it goes to QA, right? And it goes through the testing process or whatever, and then the CI/CD system or whoever signs it. Before I can put it in production, I can verify that it's been signed based on a secured base image, that my developer wrote it, and that it's been through our testing cycles. And that's what we mean by the secure software supply chain, right? That's the marketing term for it, which is as we move through each step in the process, we can verify that it's been working, right? So the other thing is image scanning. So again, this is a commercial thing, but just for completeness of the story. Once that container is running, we can do when containers get stored on something called a registry, right? It's a server to store your Docker images, your container images. When you push an image, when you send it up to the registry, when it hits the registry, we can scan it. We do a bit level scan on it. We can break it down. We know everything running in that image. And we can list all the vulnerabilities out for you. So we can say, look, this image has these known vulnerabilities based on this CVE database, and the CVE databases will be updated regularly and will rescan for you. So once you put a container in production, we will tell you if anything is ever discovered against that container so that you can go out and then remediate it, right? It's this ongoing security vulnerability scanning. A couple other things. We talked about secure by default. The idea of full TLS encryption across all the communication between the containers or the hosts in the system, and that all information is passed over a secure channel by default. And then as you deploy in production and you start getting into a little bit of some of the again, a commercial feature, users and role-based access control, right? So syncing with Active Directory and LDAP for user information, and then using that to apply granular permissions so that when you put a container in production, if it's a production version of the container, only the ops team can modify it, right? The development team can see it, or maybe they can't, right? But they can't modify it, or any level of permissions in there based on these labels that you apply. So being able to go through and ensure that only the people who should have access to those containers do it, and regardless of where it's running, right? Regardless of the system that it's on, we should be able to do that. So we already know what this is. I want to make sure there's anything. I didn't really talk about the secrets, but I'm going to use this slide because I want to get done here in the next 10 or 15 minutes. So a couple things on secrets management. This is actually new in the latest release of Docker. So what we basically do is we use Docker Swarm mode. So we're going to come up next. We're going to talk about Kubernetes. Kubernetes is a clustering and orchestration system. Docker has one called Swarm mode. And in the cluster managers, right? So the cluster is a bunch of managers managing a bunch of workers. In those managers, we can store the secrets. Now they're encrypted by default at rest in the store, right? And so, and they're encrypted while they're sent across the network. And those secrets will only be sent to systems that actually are running containers that need them. So if you've got 10 servers and only 2 of them are running the database, we're only going to send the secret to those 2 machines. They are never stored on the disk on those worker nodes. They're mounted in an in-memory file system, so you don't have to shred the disks when those machines go away because nothing was ever written to them in that regard. And the other thing we have is we have something called cryptographic node identity. So those worker nodes can't be spoofed. You cannot go in and say, oh, I'm worker 7, because worker 7 was cryptographically signed by the manager. And so we can verify that identity, right? So there's a lot of protection built into that. So if you kind of look at this right here, right? So the RAF consensus group is all those managers. That's the data store. We put the secrets up there, and you can see in the example below we have 3 workers, but the secrets are only put down onto workers 1 and 3 because that's where the containers are running, right? All the communication between those workers and the managers is encrypted. So that's what when you think about security, don't just think about, oh, did I patch this, or is the container isolated? Think about the entire end-to-end story. Think about protecting stuff in ways you actually maybe hadn't thought about before. Being able to adopt different ways of managing sensitive information. So we talk about passwords here, but you can send anything through a secret, right? You can send directory, environment variables, directory structures, whatever you want to send, like any piece of information. All right, so why do we even start? Right? So why do we even start? And sometimes I start with this and sometimes I end with it because I think it's hard to understand it if you don't kind of have a little bit more information about what containers do. So we start by, just being faster, just being quicker, right? Being able to run CI/CD pipelines on containers, and you can cut the time to do a test cycle by orders of magnitude simply because if you're booting up 100 VMs to do scaling testing, that's going to take you a couple hours potentially, and I can boot 100 VMs or 100 containers in 15 seconds. So I go from hours to seconds to get my infrastructure. And if you think again like CI/CD, I'm not managing a Java build server and a Python build server and a whatever build server. I have build servers and they run Docker, right? Or they run some container runtime, and everything comes in a container because everything my application needs to run is in the container. I don't have to do anything with it, right? That makes all the dependencies much simpler, right? The dependency to now run your application on the infrastructure side is an operating system and the Docker engine. Right? You don't ever have to worry about what version of Java is installed on that machine. Or I'm a Java developer and you want to send me Python, I have to install Python. I don't have to worry about any of that anymore. Unified toolchain. Yep. Unified toolchain. So the idea that that the CLI and the API that you use is the same on your MacBook where you're using for development. It's the same as on your Linux hosts running up in Azure. It's the same as the hosts running on vSphere. It's the same APIs, it's the same CLIs. Oh, and by the way, it's the same APIs and CLIs from Linux to Windows, right? So Docker run is Docker run wherever you type it. Docker push is Docker push wherever you type it. We talked about that, API automation. I'm going to move forward to, actually I want to talk about this stuff. So you're like, okay, cool. I don't know where to start. I heard that I have to do microservices. The reality is that you can do any number of different application paths into Docker, into containers, right? So, we talked about already like the benefits of just lifting and shifting applications. Just taking an application and moving it into a container is going to be more performant, even if you keep it in the VM. You're going to get better performance that way, right? You're going to get better portability. And a lot of people are doing that. We have customers who, we just did an announcement with a big financial company back in New York, like a Fortune 5 company, or Fortune 40, sorry, that's doing lift and shift on Windows. And they're moving a bunch of their applications into Docker containers, just straight up moving them in there. And sometimes what people do is they move them into containers and they start breaking them down, right? So they take a container and they take an application and they say, all right, I'm moving that into a container. Well, now I've got these 3 applications. They're all running in containers, and I notice they all have the same authorization, sort of authorization function. I'm going to put that in a microservice, and I'm going to point those applications out of the VM into the microservice, and they start breaking those things down, right? There's this whole continuum between monoliths, and a monolith being a traditional standalone application, and microservices, and you can be anywhere on that journey. You can put it in the container and never worry about it, or you can start breaking it down, or you can just, we've had some customers that have just said, you know what, I'm just going to blow it all up. And they blow the whole thing up, and they just immediately go to microservices. The things you have to worry about with containers as you start looking at these monolithic applications are things like fixed ports and static configs, right? When you have to define the application for different environments and you're talking about a container where everything is sort of the same, that can be problematic. But the beauty is, and this is my absolute favorite thing about Docker, and this could be my last question I ask you guys. How many of you have ever deployed an extremely complex project exactly 100% correct the first time? Oh, I saw a guy try to raise his hand over there. You guys get his number quick, hire him. You guys want that perfection, right? No, and that's the thing about Docker is that, we hear a lot of people that are like, oh, we were in the cloud and we realized the economics of the cloud didn't work. And so now we want to move back to the data center. Common example, super easy to grasp. The problem is that if you've done that and they're in EC2 instances and they need to end up over here in a virtual machine, how do you do that? Like that is a serious engineering effort. If they're in Docker containers, it's trivial, right? And what I mean by start somewhere and end up somewhere else is you are able to recover from decisions that you've later come to realize were not the right one. I don't want to call them mistakes because we don't make mistakes. Well, at least I thought I was wrong once, but I was mistaken. But you start somewhere and you do something and you're like, oh, this isn't what I want. Well, it's easy to recover from that and adjust to it and move around on the fly. I'm going to skip that. So getting started. For those of you who are new to Docker and don't have it, if you have your Linux machine, you can just do curl SSL HTTPS getdocker.com, pipe that to shell, and you'll have Docker in about 3 minutes. Now, for those of you who do not want to pipe to shell, we have full installation manual installation instructions up on our documentation. If you want to do beta builds, you could do test.docker.com. If you want to do bleeding edge, you could do experimental.docker.com. Any of those will get you up and running. All you need on the Linux side is a kernel greater than 3.1. That's the requirement, right? A kernel greater than 3.1. We've got a whole bunch of any Raspberry Pi enthusiasts in here? Anybody got Docker running on the Raspberry Pi yet? There's a company out there called I call them Hype-Riot. I don't know how they say their name, but they're basically they're all about Docker on Raspberry Pi. They're actually doing a DockerCon workshop on getting Docker running on Raspberry Pi at DockerCon this year. But if that's something you can geek out on. So even on Raspberry Pi. If you are running Windows or Mac, you want to get Docker for Mac, Docker for Windows. Easy to download. It uses the integrated virtualization on the platform it is running to be able to get Docker up and going in a matter of minutes. So I'm running on Docker for Mac. On Windows, it uses Hyper-V. On Mac, it uses Xhive. Super fast. Again, the same API, the same CLI. It doesn't matter. It's going to work exactly the same way. We used to have something called Docker Toolbox. How many of you use Docker Toolbox? How many of you love VirtualBox? Some people liked VirtualBox. We moved away from it because there were some limitations on it, and that's what we mean by OS integration for speed and stability. So if you're in the cloud, right, if you're using Azure or AWS, we actually have the ability to go out and run a CloudFormation template or the Azure equivalent, an ARM template, I think is what they are. And you can basically stand up a Docker cluster in about, well, you can kick it off in 30 seconds. You actually answer like 5 questions, and it will build you a full Docker cluster up in AWS. It'll integrate with the load balancers and everything. So if you start a service on the cluster that needs a firewall port opened, it will open the port for you, like that sort of integration. And I was geeking around the other day, and I just said, like, what could I do with this? And I deployed a 1,000-node cluster up in AWS. Like, I just said, give me 1,000 nodes. And, like, it took an hour to provision all the instances, but they all came up, and I had a 1,000-node cluster up and running. So that's pretty nice. We do that for Azure and AWS. So walk, jog, run. So you're new to Docker. Go out and install Docker for Mac, Docker for Windows, put it on your Linux box, and just do Docker run hello-world, right? Super easy. You could run Mike G. Coleman cat web, and you could get a really cool website that shows random cat GIFs in a Docker container. And then, so for me, when I came to Docker, I knew nothing about containers. So I went out and I said, what are the things that I could do? And someone said, why don't you build a CI/CD pipeline? So I went and found Jenkins, and I got a Jenkins container, and I built a Jenkins CI/CD pipeline with Docker that basically runs the test jobs, pulls the Docker file off of GitHub, builds the container, tests the container. If the container's good, if the test passed, pushes it back up to Docker Hub, right? Do something like that. Or WordPress, because WordPress has multiple components, right? Build something like that. There's 1,001 blogs on all these things. Go check those out. And then once you get that done, say, well, WordPress is cool, but I need multiple databases on the back end. How do I do a replicated database or a sharded database or a scaled database? Or that Jenkins thing was cool, but I really want a full CI pipeline, right? I want more than just getting it to Docker Hub. How do I build this so that it pushes it into production? And what does that look like? Build your own Docker files. We didn't talk about that. Build your own Compose files. Get into swarm mode. Talked a little bit about swarm mode. Didn't talk much about Compose. These are some of the more advanced features of Docker you can play with, right? So at the end of the day, I'm not here. So I made the comment, I'm here to get you the questions that you need to answer the question that you wish I would answer for you. I can't answer it for you. I can't tell you how to run your application in a container because only you should understand at the level necessary to make that informed decision. I will say that putting something in a container does not abdicate you of the responsibility of understanding how your application works and what it does. You still need to understand your applications. You still need to performance profile them, all those sort of things. And then pick the right tool for the job. Containers are not a panacea. They are not the right tool for every job. I think there's a lot of problems they solve, and I think they're obviously the motion and stuff that we're getting shows that a lot of people are happy with them, but it's up to you to decide what the right tool for the job is. And my job today was to hopefully give you some more things to think about as you go down that journey. So what's next? Go ahead and pick a project. Get your hands dirty. You will make mistakes. You will do things like inadvertently delete every image on your system or corrupt an entire cluster and have to rebuild it from scratch at 11 o'clock on a Thursday. At least I did. But join the community. So if you're not involved in the Docker community, we have, thousands of contributors, right? We have a bunch of ways for you to get involved, everything from just downloading it, playing with it, and opening issues and letting us know what doesn't work, to joining a meetup. Like I was mentioned, I'm the organizer, one of the organizers for the Portland meetup. Join our community, share what you've learned. And with that, I have about 3 or 4 minutes for questions before we need to bring up the next slide. So thank you very much. And if you have a question, let me know and we will do our best. I don't know if we have another microphone or if I should just run around. I think I have to run around. Okay, any questions? Perfect presentation, no questions. No, this guy's got a question. He's going to ruin it. I was bowling 300. So the gentleman's question was, we talked about Docker for Azure, Docker for AWS. Is there Docker for Google Cloud? I'm not sure that I can tell you that we're working on that. But I think I can. And I think so what we did had the way that Azure and AWS came out is we did a private beta where you would send in a request and we would approve you and let you in. Then we did a public beta. I'm not sure where we're at in that process, but we are working on Google Cloud, most definitely. Yep, for sure. Yeah, so the question is Docker Data Center. Docker Data Center is one of the tiers of the Enterprise Edition. So Docker Data Center is a commercial offering based on an annual subscription that gives you a graphical front end for managing containers. If you're a vCenter admin, think about vCenter for containers is essentially what Docker Data Center is. But yes, it's a paid offering. It's part of Enterprise Edition. You can get a 30-day free trial up on docker.com, but I'm not here to sell you anything. If you're just using it Docker at home, you probably don't need it, honestly. But outside of the 30-day trial edition, I don't think there's anything like that. There's some open source projects out there and some emerging things. I think Portainer's one of them that kind of gives similar functionality, not quite as enterprise ready. If you just want a graphical front end, you might want to check one of those out for more of a hobbyist thing. I'm going to come over here, and then I'll come back over here. I saw way in the back there. How does the AWS integration compare to ECS? So ECS is EC2 container service. It is basically the Amazon offering for sort of managing your containers up on Amazon. So a couple of big differences. One of the big differences is that the ECS integration is always going to be behind as far as the Docker engine goes because they have to integrate it back up. So I think they're still like on 112. So with Docker for AWS, that release is part of the core release that we do. So when we release a new version of the engine, we automatically update that CloudFormation template and all the omnis behind it. The other part of it is that EC2 uses its own proprietary sort of chain, like tool set or whatever commands. And so if your developers are over here developing on Docker on their MacBook, and then it goes into EC2 container services, it's a completely different set of APIs and a completely different CLI. So you kind of break that workflow. Essentially, they basically do the same sort of thing, but EC2 is a little more proprietary than, say, Docker for AWS. Like Docker for AWS is more open and leverages all the AWS stuff underneath it. Yeah, it's a really, really good question. So, gentleman's question was, how do you relate, or what's the practices around config management, Puppet, Chef, Ansible, and containers? And I think, I had a long conversation with the Chef guys last week at Container World about this. Most of those vendors are not going to ever recommend that you put agents inside the container, right? That you want to treat those containers as sort of immutable and they don't change. And so if you do an update to a container, that's a bad way to do it. You want to update the stuff outside and do the upgrade. Puppet in particular has done a lot of work to help set up and maintain Docker environments. So that's sort of how I see the delineation, right? How do you use them to build the infrastructure to maybe track the base images? Puppet has some tooling to do like manifest into Docker files. And then Chef is doing this thing called Habitat, which is kind of cool because it's actually like a superset of everything, right? So it it understands that containers are one way to put out applications, but there's also VMs, there's also physical applications. So they're kind of taking a more holistic approach. But most of those companies, like when they get to the actual container, managing that, they leave that to Docker, right? They leave that to the Docker file and the images. So any last questions? All right, well, thank you so much for, one more back here, yep. In the Oregon sweatshirt. Yeah, gentleman's question was, what about the performance characteristics of different workloads, and how would that impact the consolidation ratio? That example that I gave today is actually what we consider to be a fairly conservative estimate, because that was a CPU-bound application, right? And so applications that are more memory-bound, you're going to get better consolidation ratios than you will. So, but you won't know until you test the individual application. CPU-bound applications are probably going to get less of an increase, because you're just like, some applications are just going to eat as much CPU as they possibly can, right? And you're not going to be able to do much about that. We find that like memory applications that are more memory-bound seem to do a better job of consolidating, and applications that use a lot of storage, you can get really great storage savings, because we essentially have something that's akin to deduplication or thin provisioning built into containers. Like, containers are by their definition thin provisioned. So if you need to scale them out, the more you scale out, the more you save in terms of disk space. Okay, all right, with that I have to stop because time of the next speaker, but thank you so much for coming out and letting me kick off Scale. I was here last year, I loved it, I'm glad to be back this year.
Testing, 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 testing. Hello? Testing? 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 Testing, testing? Hello, hello, hello. Testing.
I don't have.
Just sound guy? Is there somewhere they usually turn it on right before the session starts.
Hello, hello, hello. Yeah, but they were having trouble with it earlier, and then the sound guy disappeared. Hello, hello. I mean, if you have a chance to actually run and get somebody, yeah. Hello. Testing, testing, testing. Testing.